while we're noodling around, oh, I need the microphone, don't I? Just while we're noodling around with the video, I'm Rob Pickering from IP Cortex. We're a comms development company just outside London in England. I'm part of a virtual team of 4 people who should be standing next to me here, but they're all in London. So I'm attending TADHack. They've been developing remotely while we've been working here. Okay, that's okay. We can work with that, I think. Fantastic. So we all got together 3 or 4 days ago and said, what should we do for TADHack? We sort of thought we wanted to do something a bit interesting. We've been working with WebRTC for a couple of years now, developing applications around it that we hope one day, when the endpoints come together, will turn into commercial stuff. But for TADHack, we wanted to do something a bit interesting. So we looked at some real-world problems out there. One of the real-world problems we looked at was emergency services stuff. So I walk out of here, I come across a casualty in the street, I get on my mobile phone, and I call them up. And what I end up talking to is a call center, maybe one of only 1 or 2 call centers in the country, and they then dispatch an ambulance. So they make some sort of verbal or maybe electronic dispatch of an ambulance. They might know a little bit about where I am from what I've said and location based on cell towers, but there's not a lot of information at that point about what's going on. That's because normal voice, 911, 112 services, they're great. They've got resilient infrastructure support. There's lots of stuff there to make sure they're always there, right? Regulators get very, very excited about them. So, you know, you've got location information that loads of people like to mandate, but the reality is it once meant something. It means nothing now. With voice over IP, I can be pretty much anywhere, not where they happen to send the bill for my circuit. But most importantly, it doesn't use anything about the features of the smartphone. This thing here knows exactly where it is to within a few meters, and it knows what's going on around it. So that might be of use to some of these guys. How do we improve that? Well, we could distribute an emergency app to every phone, but that's no good unless everyone actually downloads it and uses it. And unless it actually does cute pictures of cats or something, that's pretty unlikely. So a specific emergency services app isn't too good, or we could spend the next 2 or 3 decades of our lives in committees agreeing everyone, or getting everyone to agree a standard and mandating that operators put that onto phones and things. Maybe, maybe not. Or we can just say goodbye to all that and just overlay the features that we need by using technology that's already there in the phone. So that's what our hack does. We put together a hack that uses WebRTC and SMS to deliver real-time comms in an emergency situation. And we called it RTCEmergency. That was really imaginative, and it works like this. So here's our incoming call operator. They're sitting in front of their console, and someone picks up a phone and makes a call into our emergency number. They get to answer it by pressing a button, and our call is put through effectively. So we've got an audio stream. That audio stream's going to the operator console via a WebRTC session. So the operator's now talking to the user of the mobile. In talking to the user of the mobile, they want a bit more information. So the mobile user says, I've just witnessed this hideous accident. There's a cyclist lying on the floor. He's all floppy. I think he's broken every bone in his body. I need some help here. So they say, OK, I've sent you a text message. Can you click on the text message for me? Because that's going to enable your phone camera, and it's going to tell me a bit about where you are as well. So the user of the smartphone clicks on the message. A couple of seconds later, our emergency services operator gets some location information, because we just use the location API to send that up. So we'll see a pin appear on the map in a second. And the operator is being offered video. So the operator can click on the video button, and they're now getting the video from the camera phone. And this works really well on anything that supports WebRTC. So I've got a Google Nexus phone out of the box with current Chrome. I've got WebRTC. So the operator's a bit nonplussed now, because they can see the soft toy sitting with a cycle helmet and some gloves. And sort of they can short-circuit this call, actually, because you know what, sir, just pick up your soft toy and brush it off, and I'm sure it'll be fine. We don't need to send an ambulance. One other thing that this application can do, because we're using media streams, we can loop the media stream to the guy in the ambulance. So we've got this highly paid paramedic, really qualified paramedic, sitting in the front seat of the ambulance, and he's a passenger, right, for the next 5 or 10 minutes till they get to the accident, and I'm talking to the call center operative. Wouldn't it be great if we can run the same application in the ambulance so we can actually have that paramedic responder getting real-time video from the scene so they can start their triage, they can start their assessment. They can maybe even give advice as they're sitting there. But this application, as we put it together, only augments the real-time voice that's already there. So we're using the media stream from the GSM network as is without kind of messing with that. So if it all goes horribly wrong and we lose the ambulance and we lose the peer-to-peer connection to the smartphone, we've still got that, you know, kind of supposedly highly reliable voice to the operator. So, you know, a few caveats and things. Well, this is a hack, right? We put it together in a couple of days. Please don't come and, you know, offer to pay me to do WebRTC stuff for emergency services. And, you know, if a loved one or someone gets injured tonight, don't mess around with peer connection. Dial 112 or 911, right? And, you know, it's a proof of concept for a whole class of applications. What we're trying to demonstrate is once you've got ubiquitous support in these endpoints for WebRTC, then you can do all sorts of cool stuff. It needs a bit of work from, you know, a few people. Anyone from Apple or Microsoft in the room? No, I thought not. Okay, it needs some support from a few more vendors to actually make it useful. Thanks to the Google WebRTC team for a fantastic product. Next, Mo, we hacked together your SMS send in, I think, about 3 minutes or something, which we used in the demo, so thanks, guys. But especially thanks to Matt, Jamie, and Steve, my colleagues at IP Cortex that have been working on this for the last couple of days. Thanks, folks.